Now I'll begin to program the object that controls the motors. I'll define in the information that it changes the direction of the robot in response to a change in tone. The first thing I'll put in this object is another object that detects if there is a change in audio. It'll be a task object that's named Detect Change in Audio. Within this new object, I'll need to create a way for the frequency of the audio to be compared to the previous state. The value of audio frequency is stored in register 16 as a binary number. If I copy the value of register 16 into another register, it will give me a way to compare the two states of the audio. With a change of audio, the value in register 16 will change, but the other register will still have the previous value. Comparing the two registers will tell us if there is a change in the audio. I'll begin by placing in the compare block and configuring for register 16, which is the audio inputs value, and an unused register number 28. Then I'll configure register 28 to be an integer and to be named audio detection. We'll need a way to indicate to the rest of the program if these two registers are the same. To do this, I'll turn on a flag if they are not the same, and turn it off if they are. By placing a control block at the no branch, I'll be able to turn on the flag if the registers are different. I'll pick an unused flag, and then I'll name it audio change. Then on the same no branch, I want to set the audio detection register to be the same as the inputs value. This will reset the compare test and allow a yes when the audio is done changing and is settled at a frequency. So I use a move block to copy the value of register 16 into register 28. At the yes branch, I'll turn off the flag, so that it is only on when the audio is changing. And complete the object by writing its information, that it turns on the audio change flag when the audio is changing, and turns it off when the audio is not. Then I'll paste the detect change in audio object into the flowchart. To run the LEGO NXT motors, we'll need the left and right motor control objects. These objects are never done, so the automatically placed done tests are not needed. To run a motor, you first need to give it a direction by turning on or off the flag associated with it. Turning flag 0 on is the left motor forward direction. Turning it off is the same as reverse. You will also need to turn on the flag that says run for the correct motor. So now the left motor will come on in a forward direction with a speed of 4. I want the robot to pivot on one wheel, so I'll move a value of 0 to the right motor. And then I'll add the decision block that checks if the audio is changing. I'm going to swap the yes and no connectors and loop the yes. That way the program can't continue unless the audio is not changing. Then I'll add another decision test, but I'll swap the connectors and loop the no. The two decision blocks will cause the program to wait for the audio to go through a period of no change and then to one of change. Now I'll change the values to make a different turning motion. I'll turn on the right motor and give it a forward direction, and then change the speed of the left motor to 6 and the speed of the right to 4. Then I'll add the same two decision blocks to make the audio change flag turn off and then on again. So far, the robot will begin by pivoting on its right wheel, and when the audio changes, it will start a wide turn in the same direction. Now I'll add a pivot in the opposite direction and then a wider turn the same way. I'll move a value of 0 to the left motor and a 4 to the right one. Then I'll add the two decision blocks and I'll move a 6 to the right motor and a 4 to the left. And then add the two decision blocks and now I'll loop the program back to the beginning of the sequence. I'll connect all the lines and it'll be done. So this program will cause the robot to transition to different turn motions when a change in audio is analyzed. So now the program is done, and I'll try to compile it by clicking on Download and Go. Okay, looks like we got a few problems. I'll just select Go to Error, and Flowpro will take us to the problem. Looks like I missed a connection. There can be no unconnected lines like in cell A3, so I'll add a move block to move the value of register 16 to itself. This will not affect register 16, but it will allow us to see the value in the monitor window. And I'll just loop this back onto itself to connect all the lines. The melody causes a constant change of direction in the motors, which makes the robot travel in a semi-straight line. The brief pauses in the music allow the motion to continue in a single turn. By playing the melody and using pauses, I can keep the robot in the area. Well, that was my project, and good luck with yours.